Good day, sir. We are here to present you about the noise topic. So, we are the group of Labian, Magpusang Mamado, Ray, Rosales, and Villar. So, noise. Noise is like an attenuation. It is something that is blocking or disturbing the desired signal from the sender to the receiver. It is undesirable electrical signals that enter in the communication system. So, what is noise in communication system? The primary source of noise in communication system is the channel. Although systems that transmit or receive data can also generate noise. There are two mainly types of noise sources. It is the internal noise and external noise. For the external noise, there are two types. It is a natural and man-made. So, next please. So there are four noise effects. The decrease in efficiency of analog and digital system. It is the first. The second, the sender is incomprehensible to the recipient. The third is the receiver is unable to perform as it should. Fourth, it decreased the communication system effectiveness. So noise versus interference. Noise is an unwanted signal which affects wanted signals, while interference is generated by other signals. So it's like an artificial noise. Next presenter, please.
So for the classification of noise, noise may be put into following two categories. The first one is the external noise and the second one is the internal noise. So for external noise, noise whose sources are external. External noise may be classified into the following three types. The first one is atmospheric noise. Second one is the extraterrestrial noise, which has a solar noise and cosmic noise. And the last one is man-made noise.
Internal noise. Internal noise are noises generated within the receiver or communication system. Internal noise may be classified into the following types: thermal noise, shot noise, transit time noise, and miscellaneous internal noise. Thermal noise is the type of noise that is generated by all resistances and is represented by the formula shown at the screen. Next slide, please. Shot noise. Shot noise is produced by the random arrival of electrons at the output element and is represented by the formula shown at the screen. Next slide, please. Transit time noise is the result when a signal frequency's period is the same as the time an electron takes to travel from sender to receiver. Next slide. Miscellaneous internal noise are composed of flicker noise, intermodulation noise, crosstalk, impulse noise, interference, burst noise, and avalanche noise. Next presenter, please.
Signal to noise ratio, it is one of the most important factors that you have to consider in every link of a recording chain, right from the microphone placement to the preamp we use and the various effect that we put in the audio throughout the process. Because if you know, the goal of recording is to capture the purest sound with a little noise as possible. And the more noise there is within a sound, the more it will worsen. It sounds quality and it also makes harder for that part to punch throughout a mix. We all know noise is anything that interferes with the communication process between a speaker and an audience. Next presenter.
Noise figure is a measure of the degradation is signal to noise ratio and can be used in association with radio receiver and sensitivity, and it's in a receiver sensitivity, and it's an essential element of the RF circuit design of any radio receiver. Noise figure is a number by which is performance of radio receiver, amplifier, mixer, or another circuit block can be specified. Next.
Noise temperature is generally used to present how much thermal noise is generated from active or passive devices in the receiving system. In order to describe how much thermal noise is produced by active or passive components of the receiving system, the phrase noise temperature or thermal noise is typically used. The noise in a system can also be expressed as an equivalent noise temperature, T sub E, at a pair of terminals, the temperature of a passive system having an available noise power per unit bandwidth at a specified frequency equal to that of the actual terminals of a network. For example, the noise temperature of a simple resistor is the actual temperature of the resistor, and the noise temperature of a diode may be many times the actual temperature of the diode. The relation between the noise figure and equivalent noise temperature is as follows. F equals 1 plus T sub EQ over T sub 0, where T sub EQ is equivalent noise temperature in a receiver or amplifier, T sub 0 is equivalent noise temperature in a receiver or amplifier, and F equals noise figure. The noise in a receiving system can be of thermal origin or can be from other noise generating processes. Most of these are other processes generated noise whose spectrum and probability distributions are similar to thermal noise. Because of this, all noise sources contributions can be grouped together and referred to as thermal noise or not noise temperature. The minimum signal level that can be detected in is limited by the thermal noise captured by the antennas facing a black body, which is at a room temperature of 290 Kelvin or 17 degrees Celsius or 62 degrees Fahrenheit, and noise generated within the subsystems of the receiver. The thermal noise is commonly characterized by an power density P sub n given by P sub n equals K T sub n B, where K is Boltzmann constant 1.38 times 10 raised to negative 23 joules over Kelvin, but B is the bandwidth in Hertz and T is the temperature in Kelvin.